Let's take a moment to recap where we are. So far, I have outlined the problem statement and the need for a systematic approach to security. We have looked at two frameworks, OWASP SAMM and NIST CSF, and how they help bring structure to your application security and cybersecurity program. I've also positioned the role of metrics as key enabler when introducing these frameworks into your organization. In the final part of the session, I will give you a high-level overview of the science behind effective metrics. Then we'll have some fun looking at dashboarding worst practices. Metrics are one of the most underestimated problems in security. In my opinion, as a community, we often rely on whatever metrics come out of our tools, plus a bit of intuition here and there, rather than anything grounded in the actual science. So here's a little thought experiment. Take a look at these metrics and ask yourself the question, do you think they're good indicators of how effective your security program is? I see these all the time, and honestly, none of them are great. Take number of vulnerabilities, for example. It sounds useful, but the correlation with actual risk is weak. Most vulnerabilities, based on some data up to 90%, aren't even exploitable. And for the ones that are, you often only get a technical impact score, not business impact and not likelihood. So you could have a high impact vulnerability sitting in your admin panel, but it can only be exploited by an authenticated administrative user. Clearly, the likelihood of a highly trusted admin user exploiting the system by using a vulnerability is very low. A better metric? How about number of exploitable vulnerabilities in production with likelihood factored in, triaged by the security team? Then there is number of training hours. This one is actually easier to poke holes in. Just because someone sat through training doesn't mean they've understood it, they've retained it, or even they can apply it in real situations. Also, it says nothing about the quality of the training itself. So in the next part of this session, we'll break it down and look at what makes metric truly useful, and we'll explore the anatomy of a good metric. Before we dive into the science of what is a good metric, let's start with a simple but powerful framework, the Go Question Metric Framework. It might sound obvious or even a little silly, but in practice we often get this completely backwards. In industry, we tend to start with the metrics our tools give us, and then we try to somehow work backwards and map them to goals. That is the wrong direction. The GQM approach flips it. You start with a goal, a clear objective you care about. Then you define questions that help you understand whether you're making progress towards that goal. And finally, you identify metrics that can answer those questions. Take the number of vulnerabilities from the previous slide. Our goal is actually to reduce the risk of getting breached due to a known exploit. That's a sample goal. It doesn't have to be exactly that, but that's a good goal. And to answer that goal, we need to ask the questions, how often do we have exploitable vulnerabilities in production? Not just low, medium, high, or critical. How often, how many exploitable vulnerabilities are in production? And then how many of those vulnerabilities could actually lead to a breach? The fact that you have an exploitable vulnerability in production doesn't necessarily mean it leads to a breach. As I've given in the previous example with the admin users, if you have an exploitable vulnerability in the administrative section of your system, even if the admin user exploits that, he already has access to all the data in the system, he or she, which means that administrative user is not going to use that vulnerability, hence that vulnerability is not leading to a breach. And then a set of metrics to help you finally answer those questions could be number of exploitable vulnerabilities in production, impact score of each exploitable vulnerability, and likelihood of each exploitable vulnerability. So you start with the goals, ask the right questions, then choose the metrics to actually answer those questions. There is a good exception to the goal question metric approach though. Sometimes you simply don't know what you're looking for yet. That's where qualitative analysis comes in. You might start by collecting raw metrics, not because they directly answer a question, but because they help you explore and understand the phenomena behind the scenes. Take a metric like level of effort, the number of hours worked per specific issue. At the first glance, it's unclear what exactly you're measuring or what decision it supports. But that doesn't mean it's useless. In fact, I recently had a long and fascinating conversation with a fellow SAMM core team member about this. We realized that tracking effort over time can reveal patterns, which issues are dragging your teams down, which types of findings are disproportionately expensive, and where you might have hidden process problems. So even if you don't have clear goals yet, exploratory metrics like this can help you make sense of complex systems. They give you the context you need to eventually ask the right questions and then apply GQM with much more impact. That said, the rest of this training will focus on quantitative analysis, specifically what makes a good metric when you're trying to measure a known phenomenon.